Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Right, for this question, which is actually amplitude modulation. So how do I know that this is amplitude modulation? Because can you see the amplitude changing but frequency is constant. So therefore the form of modulation here is amplitude modulation. So the next one is to find the frequency of the transmission, which is this frequency. Now remember, the frequency of the amplitude modulated wave follows the frequency of the carrier wave. Like for example, if this is a carrier, this is the information, then the amplitude modulated wave will follow this frequency. So to find this normal frequency like this or like this is the same, right? So you just find the number of cycles in a certain time, because to find the period for one cycle is a bit hard because you can't really see one cycle what is the time here. So like in this case, from 0 to 100 microseconds, you'll see there's 1, 2, 3, 4, 5 cycles. So the frequency is 5 over 100 microseconds. Now what about the frequency of the modulating waveform? Now what is the modulating waveform referring to? Now this is called the carrier wave, this is called the information signal. So the information signal will modulate the carrier wave. So this is called the modulating waveform. That means the frequency of the information signal which they want here. Normally, to find the frequency of this wave, we will find the period which is from here to here, right? We find the period which is the time from peak to peak, then 1 over that. But since we are given this, so we have to realize that the highest point here, or the peak here, corresponds to highest amplitude. The peak here also corresponds to highest amplitude. So what we can do is to find the period of this, we can find from here by taking the time from biggest amplitude to biggest amplitude. But in this case, from biggest amplitude to biggest amplitude is 200 microsecond. So 1 over that will be the frequency of the information signal. So the next part of this question is to to draw the signal voltage versus frequency. So this is the frequency spectrum graph. So remember what they said, the middle must always be a carrier frequency, which is the in this case the previous part we found is 50 kilohertz. And remember, these two are your side bands. One is FC plus FA, one is FC minus FA. So since your FA is 5, so FC plus FA is 55, FC minus FA is 45. So now these are all standard hidden waves. Now these are your hidden waves in that amplitude modulated wave, right? And remember, when you draw these two lines, the height of this must be between, the height of these two must be the same and must be in between 1/3, right, or to half of the height of this line. Right, for this type of question, when they ask you for the type of modulation, this is also standard, this is amplitude modulation, because only amplitude modulation would be 1 FC and 2 side bands. Now for frequency modulation, you will find that they will have multiple side bands, which gets smaller and smaller amplitude on the sides here. But if you don't see all these multiple side bands, then it's definitely AM. But anyway, the multiple side bands, which is the frequency spectrum graph for FM, is not in your syllabus. Alright, so the next part, what is this frequency component called? This is actually called your carrier frequency. And what is the components, these two components called? These are called your side bands. So state the bandwidth. So the bandwidth you can obtain by taking the highest frequency component minus the lowest frequency component, which is 10 kilohertz. Right, so for the next one, they want you to draw the voltage versus time for the whole amplitude modulated wave. So what you see here is actually when you have amplitude modulation of the carrier wave already, the whole thing. So how do I do it? Now remember, from the graph earlier, we saw that the audio was 5 kilohertz and the carrier was 50 kilohertz. So what's the first thing you should do is to actually convert the frequency to period. So like in this case here, 5 kilohertz, 1 over that is 200 microseconds. 50 kilohertz, 1 over that is 20 microseconds. So you need to convert it to microseconds because your graph here is in terms of microseconds. So what is the next step? Our next step is to make an outline so that you can draw the amplitude modulated wave accurately. So you remember that the period of the audio is 200 microseconds. So in other words, in one cycle, you start from 0 here and you must end back at 0 in 200 microseconds. Then what you do is in the middle, which is between 0 and 200, at 100 microseconds is again another 0. Alright, and in between 0 and 100, which is 50, you will draw a peak, and in between 100 and 200 at the bottom is a trough. So now this line that you draw is just a reference line, temporary line that you will need to erase later. This is just to give me a general outline of the information signal. Then after that, remember, right, the amplitude modulated wave will use this outline as an envelope on top and bottom. So what you got to do now is you take this line and then you just shift, draw another line up there, just slightly up there, so that you get the same shape here as in here. Okay, now this is just an estimation. You don't have to like be specific. Some you draw bigger, some you draw smaller, as long as the shape here matches the shape here. Now after that, you can erase off this blue line, and then the next thing you can do is from here, imagine there's a mirror, and then you reflect this line to over this side. So that means you try to estimate, like whatever gap here you plot here, 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 whatever gap you plot here. Then you make this dotted line as a guide. Then after that, you can draw your carrier wave, which is 20 microseconds, right? So you draw every 20 microsecond one wave. And then you make sure, right, that this is your guide, that your envelope here is a guide. So just follow along this guide. Every 20 microseconds, draw the period of the carrier wave, and then you will get this nice shape. Right, in this next question, they are talking about a amplitude modulated wave, but this time, right, the music has a range of frequencies from 30 to 4500 Hz. So the radio station is broadcasting the long wave waveband, which is the wavelength given here. So what is actually the long wave waveband? Actually, all the frequencies that are available for wireless transmissions, which range from 30 kilohertz to, let's say, 300 gigahertz, all of these, right, are subdivided into different like ranges for different categories. Like for example, the long wave radio, which is a type of AM radio, is occupying from 30 kilohertz to 300 kilohertz, which is from these two wavelengths. If you convert this wavelength and this wavelength to frequency using V equals to F lambda, where V is the speed of light in vacuum, you will get the frequencies of these two to range from 30 kilohertz to 300 kilohertz. So that is the division that every regulatory body in the country has to make. So what frequencies are used for what purpose? So for this question, this is your range for the long wave radio. So how to find the bandwidth? So to find the bandwidth, remember we said that we can always take 2 times the highest frequency component. So you have your highest frequency component is 4500 Hz. You multiply by 2, then that you get 9000 Hz. So that is your bandwidth. Now, the maximum number of radio stations that could operate simultaneously in this same area. So what you have to do is what I told you. You have to convert these two to frequencies using V equals to F lambda. So what you will notice is that the long wave waveband occupies from this frequency to this frequency. So between these two limits of the frequency, how many frequencies you have in between, you minus the 2. So when you minus the 2, you get the number of frequencies available, but each station occupies 9000 Hz, which is the bandwidth. So you divide by 9000 Hz, so you get how many stations can operate. And then if you have to plot the frequency spectrum graph, now they didn't specify the carrier frequency, so we just label it FC, but they did label the audio from 30 to 4005. So you get FC plus 30 all the way to FC plus 4005 on this side, and then on this side will be FC minus 30 all the way to FC 4500 on the other side. But make sure again the height here is between 1/3 to half of the carrier frequency.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.